Good evening, everybody. My name is Conrad Vargas. I'm glad to see everyone here, because you live in an area here that geologically is very unusual. There are some minerals that come out of this area here that are just striking, because these volcanoes here are so unique. You have volcanoes all the way around the valley that reach clear past 29 Palms. A lot of people think that these hills here are what we call uplift, but they're not. When I was in high school, I had a good science teacher who said that all volcanoes came up out of the earth here, forming your volcanoes. He was a good science teacher too, but that's not right. Volcanoes basically do not come from the very core of the earth, which is solid iron. We have iron here, which is kind of unique, and I'll get into that. But your volcanoes do not form down in here and come protruding up. We have on our coast here what we call Pacific plates. The Pacific plates are, let's start here with the earth here, our coastline. The plates, Pacific plates, are sliding underneath the continental plates. The plates, because they're sliding underneath this landmass here constantly, they create an enormous amount of heat. Enormous amount of heat. They are tectonic, you're absolutely right. What happens when they push underneath the plates? On the California coastline, Oregon and Washington, all the way into Baja, California, when they push, because it's a loamy soil here, sandy soil, we have what we call the coastal ridge. I think if you've been along the coast, you'd see all the way up, there's a little ridge, maybe 2,000 feet, and then it goes back into a valley. Then the plates are still pushing. Then we have, in this case, let's call them the Sierra Range. Their pressure is pushing them. Those are called uplifts. On the California coast, we have what we call Seven Sisters volcanoes right on the shoreline. Morro Bay, if you've ever been in that way, Morro Bay is one of the most graphic little ones that comes up. All along the coast we have these little volcanoes, and they're quite old, and of course they're all dormant. Now we have the coastal little short ridge, and we have the Sierras, and we come down. We have Death Valley here, which is on the opposite side. Whenever something pushes up, something is going to drop down. I made a mistake here. Sorry. The next ridge is above LA and the San Jacinto Mountains. Let me draw that larger here. I have all this whole big, beautiful blackboard. On the other side of the San Jacintos, again, it's below sea level over there. Where you have an uplift, the land on the other side is going to recede. Then we have the Sierras. Again, it drops down below sea level again in Death Valley. So as you have an uplift, the ground on the other side must drop. Then we have the Sierras, they must drop. Now, why is there a gap between these here? This pressure here does not like to push through rock. If it does, it'll lift it up. If it's a loamy soil like we have here, It doesn't want to push it up. It just wants to just slide along until it gets to the Rocky Mountains. The next mountains that rise up are your Rockies, which are clear over here. Does anyone know where the Rocky Mountains actually start?
Course.
The Rocky Mountains actually start at Flagstaff. Those first mountains there are the start of the Rocky Mountains, which run way down. Now, there's this long plain here. There's no uplift because the soil is sandy, loamy. When it hit the Rocky Mountains, we had a lot of rock in there, and that's what's going to, the pressure here is just going to shove them up. Now, I'm going to talk about volcanoes but this is, you have to know, you have to understand this before we get to volcanoes.
We're not going to have a test on this, are we, Conrad?
Pardon?
We aren't going to have a test on this or anything, are we?
Yes, you are, and you must pass. Now I have a handout here.
Hey, Connie, can you put some blue marks where the water is, where the Pacific Ocean is?
I'm sorry.
Can you put some blue marks where
You have to speak up.
If I can get my wife to pass these out.
My wife don't yell like
Okay.
I want to keep one.
Okay. I made 16 of these, so.
While she's passing those out, I mentioned here that the heat and the friction on this plate that's sliding underneath the Pacific plate, it's very hot. Now, what happens is, as this ground level, you're going to, because of this heat, you're going to have volcanoes form up through this area here, creating volcanoes. Now, basically, we find most of the volcanoes on what we call the Sierra Range, which is Mount St. Helens. There's a picture of Mount St. Helens here. They're on that second push up the coast on the Sierra Range, what we would call the Sierra Range, and they go clear up the coast up into Oregon. A lot of those volcanoes are still very active. Mount St. Helens has proved that. But as we get inland, we don't find any volcanoes still active. Only on that one ridge where there's an enormous amount of heat pushing up, going up the coast. Now, this area here, so we can dispel the thought that these are all uplift. If you look at the ridges that are running this way, east and west, uplift can only be a ridge that's running north and south. The uplift can only be ridges running north and south. We have a lot of these are running east and west, which shows that they're volcanoes. I've had several people say, no, these are all uplift here. No, they're not. I'm sorry. Now, the thing about these volcanoes we have here, we have east and west right back over here. And then we have some that are running this way, which are over here. Then Eagle Mountain is running this way. And then we have some that are running all over around the valley. We're sort of encircled by these. These volcanoes here are unique that you don't find too many cones on them, as we would call a cone, where you look up and you see it was a volcano cone. The ground here, because it's sandy, loamy clay, it formed cracks in here where the heat coming from underneath here actually caused a whole row of volcanoes all the way along here. So these volcanoes here didn't erupt in one massive cone. They actually seeped up through the ground. And we have these volcanoes that you're going to find, if you look, you're going to find little cones. Only this one doesn't want to work. You're going to find cones on here. If you look across on this ridge over here sometime, you're going to see little cones. But basically, the lava came up through the ground and that whole long ridge. Now we have a unique one here in Chuckwalla Valley that I think is so gorgeous. You have a volcano right behind Desert Center, and that's called a dike, which dikes are very rare, very, very rare. The lava came up straight up out of the ground in a narrow column, and if you look at the top of that one right behind Desert Center, it's actually sheer, but they have stuff is falling off of it, and it's actually letting that cone, which is a dike, be visible. They're rare. I've only seen about 3 or 4 of them traveling all over the country, and we have one right here at the center, which is so uniquely beautiful. The thing about the dike, and it shows that the lava came up in a long strip instead of being in a long, tall cone. That one is so beautiful. Now, these other volcanoes around in the area, you don't see any lava flows. It didn't come up as lava, that as we know it, lava, which is a dark, it can be obsidian, it can be a lot of other things, but what's coming up here is granite. Granite is basically what all of these volcanic actions are around in the valley here. And a lot of people say, well, granite is always white. That's true. But we have something here called desert varnish. The sun hitting the granite will actually turn it black. If you chip underneath that black varnish, you're going to find it as white granite. This one shows granite nodules, along with, on the other map, you look at Half Dome and Yosemite and El Capitan. Those are not volcanoes. They're granite, masses of granite that were pushed up with the heat underneath pushing the granite up. But they are not volcanic. The mountain range being pushed up pushed those huge granite monoliths up to the point where they're way above the ground. But again, they're not volcanic, but yet they're caused by the uplifting of heat underneath pushing them up. Now we have Devil's Tower on that first one that I passed out to you. Devil's Tower is lava, but in it, and there's one other one, it's not on this map, I thought it was. It comes up actually octagon shaped like a bee honeycomb, and what it does, it holds together so well that the dome itself is just not going to collapse over any length of time. Now on that first one I passed out on the right hand side, that's Obsidian Point. That's down at Salton Sea. We have a volcano down at the Salton Sea where it came up with black, dark, beautiful obsidian, and that picture on the bottom right is a piece of the material that came up there. That volcano, probably about 20 million years ago. The age of these volcanoes here is about 10 million years. They're quite young. So we have a lot of destruction by the granite coming down on the valley floor here as gravel. You've all walked on it. All that sand that you see out in gravel is from this volcanic action here. So a lot of people, you know, they're awfully dark. There's an awful lot of sand here. They sure did seem to erode a lot. And yes, they've eroded a lot because this whole valley is just filled with the granite that has been flushed down from here. The thing about these volcanoes that are so unique is that instead of being in a cone, they broke the surface of the ground and came up in long strings. The volcanoes here have brought up some very beautiful minerals that can be found only in this area. The volcanoes here brought up gold. We have geodes and we have beautiful quartz. And about 50 miles from here, peridot. Peridot is a very valuable gem when it's faceted. It happens to be the August birthstone. And these came out in what we call volcanic bombs. They actually are teardrop shaped. They're thrown into the atmosphere and they come back down. And inside of these bombs, we can sometimes find this peridot. My wife just brought a very small sample from our home in Thermo. I have some bombs that are 3 feet long. And we're going to talk about volcanic bombs today. Yeah, we're talking about volcanoes every once in a while. These are volcanic bombs that are thrown out of volcanoes. They even look like bombs, don't they? Well, there's a unique thing about these bombs, and they come from local here over by 29 Palms. These, a lot of times, have gemstones inside of them. They have peridot, which if you know about peridot, you know that it is the August birthstone. And they weigh 200 pounds. They're heavy, and sometimes inside they have the peridot, and I'm not cutting mine open because I don't want to take a chance on ruining them, because we cut one open, there was nothing in it, so I'm not doing that. We have geodes here that come from this area, and we have what we call fire agate, which comes from Coon Hollow, and some of the geodes that are formed, not necessarily from this area, are absolutely just magnificently beautiful. The area here, the iron mine over here, is unique. I was showing you that the very center of the earth earlier, the core of the earth is solid iron. We really shouldn't have any iron here. But somehow or another, in the depths, it became so heated. Wow, this pen is, Renee, you got a lousy pen, brand new. The core in here somehow or another seeped up into the other area. You have to remember that the first part of the strata here on the earth is all granite. Granite is the lightest material, and that's what you're going to have mostly. But it seemed to come up in here and came up through the earth into the Iron Mountain area, but you're going to find most of these hills do have iron in them. You know, the iron is not rare to just Eagle Mountain. We find iron all over the area. But somehow or another, when the plates came down through here, they picked it up and put it up here. I think the only mineral that we don't find here, which is rare, is diamond. Diamond is the only thing that we don't find in this area. You find diamonds in Tennessee, and Arkansas. I have to have her sometimes. I don't even know how to pronounce Arkansas because it doesn't spell that way. So we're getting the iron here from the core, and there's really not necessarily any way to explain that, but we have it here. And if it weren't for the volcanoes, you wouldn't have any Iron Mountain over here. Kaiser wouldn't have made a lot of money. The thing about what comes up through here, where you have the granite just under the core of the earth, which is about 20 miles thick. And underneath here, you're going to have other things, other types of minerals. Drilling cores, they find all kinds of things which are not found in the upper core. And the Russians have probably drilled the deepest of anyone. They've been able to drill 30 miles. But they can't get down into what the hard stuff in here. There's another layer in here. They can't get into it. My wife asked the other day how deep, how far from here to here is 3,000 miles. From ground level down to the center of the cores, 3,000 miles. So that's quite a lift for the iron to come up here. And your other minerals also. Now, I have some here. I have these geodes, which I've mentioned, a couple of them. At Hauser geode beds, just about 45 miles. No, not 45. Pretty close here anyway. Hauser geode beds, where we get some fantastic geodes. They're formed by volcanic action, where the volcano throws these things up into the low atmosphere, pretty far up. But what happens is, as they're formed, they have an air bubble inside. It's a gas bubble that's inside of this geode. When it goes up into the atmosphere, it swells a little bit, not too much. But when it comes back down, it lands on the ground. Now we have a chemical action where chemicals get inside of this geode and form sometimes the most beautiful crystals. I have one here that has both quartz and amethyst. Absolutely gorgeous. And these are all chemicals that seep in through minor little cracks in the shell. The chemicals get inside and form these beautiful crystals inside. Now I have this one specimen here of what we call fire agate. Again, everything here is volcanic. Everything comes from the chemicals that are put down on the ground from the lava and from the volcano in a form where the chemicals react with each other in here and form this beautiful piece of fire agate. This is a very unusual specimen. You aren't going to see them that large. Again, the peridot, chemical reaction, chemicals got into the stone and formed the peridot. Now, the geodes, some of these geodes didn't come from here. But every one of these geodes will have a different reaction to the chemicals that form inside, that escape inside into the stone. Quartz. Quartz is very common here. These are not really good faceting material, but there are some beautiful quartz crystals that come from the area. I didn't bring any silver with me, but I did bring some gold that came basically from this area here. I have some nuggets here that we find all over these mountains. A lot of gold is found in here. These came from right here. Here's some gold and quartz came from the Box Canyon area. They came here locally. Now we have another situation. We have petrified wood. This piece here is from Arizona. This piece of petrified wood here comes from over in Martinez Canyon, which is down in the Chuckwalla Valley. The volcanoes, when they erupt, and you have forests nearby, they throw the ash out, and the ash covers the trees. This was not a very big tree, but we have one at the house. It must be 5 feet around. The ash covers the trees, and they dry out, and then chemicals seep into the tree, which create a fossilization. And over at Martinez Canyon, they're all dark. None of them have any color because the chemicals that seeped into the tree did not give it the beautiful color that this one here that's been polished. Now, geodes again are not always hollow. If I cut this one open, it probably would not be hollow at all. Now, we've made some bookends out of some of these geodes, which they're always unique. We have some very beautiful ones at the home that are hollow.
The cones that are out like up by Amboy and over by Baker, those Those are regular cones.
Those are cones.
They're small.
And yeah, they're very small cones. That's where this came from, over by Amboy. Yeah. The volcanoes over there, they did, friction-wise, they just came right on up instead of being like we have here all around the valley. The volcanoes came up in long strings, came up through. Well, that ridge right behind here is the best example of that, what we call a dike. It comes straight up in a narrow column. And it's starting to degrade over centuries. It's degraded to so you can actually see it beautifully. Then all the granite that you're walking on now came from there. On that last flyer that I passed out to you, it shows some granite domes.
That's almost like
That bottom right picture is right here behind Desert Center. And the picture to the left of that one, on the left bottom, there is a dike right next to the granite dome. So lava came up in a dome and a dike right next to the dome, which was pushed up in the form of lava. The second flyer has pictures. The very top picture shows Gator Ridge, as everyone seems to call it, and it shows the dike quite evident there on that picture. Every once in a while I meet someone who thinks that all of these mountains here were pushed up. Cannot be pushed up if they're running east and west. They have to be running north and south to be uplifted. Please come up and take a look at these specimens if you wish. You're more than welcome to look.
I have one similar to this, only smooth.
Oh, there's so many different. There's so many of them.